In this problem, we're given a population where each member of the population has one of 5 blood types, and the probability of each blood type is given by P1, P2, P3, P4, and P5. Now in this population, a crime gets committed. So crime gets committed by 2 individuals. Now we have one suspect, and our suspect has blood type 1. And the prior probability of guilt of our suspect is P. The forensic team arrives at the scene and tells us that one of the criminals has blood type 1. Second one, the second criminal, has type 2 blood, has blood type 2. And what we'd like to know is whether the probability of guilt given this evidence is larger than the prior probability of guilt, P. So let's use Bayes' rule and the law of total probability to compute this posterior probability of guilt. So this is P of G times P of T given G over, now using the law of probability, law of total probability, P of G, P of T given G, plus the probability that our suspect isn't guilty times the probability of the evidence given that our suspect is not guilty. Okay, so the prior probability of guilt is P. Now, given that our suspect is guilty, what's the probability that one of the criminals has type 1 blood and the second one has type 2 blood? Well, if our suspect is guilty and our suspect has blood type 1, we're given this information, then the probability of T just boils down to the probability that the second suspect has blood type 2. And the probability of that is P2. So over P times P2 plus the probability of our suspect not being guilty is 1 minus P. And now, given that our suspect is not guilty, what's the probability that one of the criminals has type 1 blood and one of the criminals has and the other one has type 2 blood? Well, that's 2 times P1 times P2. And the reason for the factor 2 is that the first criminal could have blood type 1, the second criminal have blood type 2, or the first criminal could have blood type 2 and the second criminal could have blood type 1. And the probability of each of these scenarios is P1, P2. And so this is the reason for the factor 2 here. Now we notice that the numerator and the terms in the denominator all have this term P2 in them, so we can cancel it out, factor it and cancel it out, and we're left with P over P plus 1 minus P times 2P1. And so now the question is this posterior probability larger than the prior probability, P? So is this larger than P? Or if not, what does it depend on? Well, the answer is it depends on P1. So if P1 is less than a half, then the posterior probability is larger than P, than the prior probability. And this makes sense because what this statement says here is that blood type 1 is in fact rare. So if we observe blood type 1 at the crime scene and we know that our suspect has blood type 1, that is evidence in favor of our suspect being a criminal. Whereas if, for example, P1 equals a half, then half the population has blood type 1. So observing it at the scene does not really tell us anything about whether our suspect is one of the criminals or not.